The drill press is essential for making clean, precise holes. This drill press is not typical for a wood shop. This drill press is more a metal machining drill press. Since our machine shop is larger, we have more of these drill presses by proxy. So you'll be seeing this machine in the wood shop and the machine shop. This machining drill press is comprised of a drill spindle mounted above an attached support table. This drill press is gear driven, not belt and pulley driven like most woodshop drill presses. The spindle plunges straight downward towards the table by use of the feed lever. Normally, the table is set at 90 degrees perpendicular to the spindle and creates perfectly perpendicular holes. This table is adjustable so that angle holes can be drilled as well. The chuck located at the end of the spindle holds the bits. The drill press can be used with a variety of bits and mandrels, including drill bits, countersink bits, spade bits, Forstner bits, step bits, and hole saws. Along with creating through holes, the drill press also has a depth gauge, which allows for depth-controlled drilling. Like mentioned previously, although this drill press is capable of drilling metal, metal is not allowed in the wood shop. Wood and plastic only when you're in the wood shop. Before we drill, let's get familiar with the parts of this drill press. On and off buttons. Press the green button to turn the drill press on. Press the red button to turn off the drill press. Emergency stop. Press this button to quickly cut power to the drill press. If the drill press does not turn on, you might have to reset this switch by turning it. The switch will pop out when it's reset. Forward and reverse and high and low speed. The L1 and L2 settings are forward and used for drilling. It's very unlikely you'll use reverse speeds, but don't assume the drill press is always set to the forward speed. It can happen to you. If your drill bit is not cutting, check to see if the machine is running in reverse. Guard. The guard needs to be in the closed position, shielding you from the drill chuck. The drill press will not turn on if the guard is in the out position. Chuck. This holds the drill bits. Chuck key. This aids in tightening the chuck's grip on drill bits. You'll typically find this against the wall behind the drill press. Drill press lever. This is the feed part of the drill press. Pull down on this to extend the drill press. Speed or gear selection levers. These adjust the spindle speed. Depth gauge stop. Use these knurled rings to stop the drill press at a set depth. This will aid you in creating holes, each with a consistent depth. Table. Your work will always rest here. Table lock. This keeps the table locked in place. This crank is for adjusting the table's height. When you have your holes marked, you are ready to drill. Let's walk through the steps to use the drill press. Check the setup of the drill press. This includes the table height, table angle, plunge depth, and spindle speed. Make any adjustments necessary. The most common adjustment is the table height. To adjust the table height, release the lock and crank the handle on the opposite side. When the table is unlocked, it can also rotate, so check your alignment if you are adjusting the table. Tighten the lock when you have the table where you want it. On the drill chuck, open the jaws wide enough to accommodate the bit you've chosen. Insert a drill bit into the chuck and spin the chuck to loosely grip the bit. When closing the drill chuck jaws, check to make sure the bit is straight and the jaws are only clamping onto the shank of the bit, never the flutes. You can spin the chuck a few times to see if you've gripped the bit on center. When you verify the bit is gripped on center and only clamped onto the shank, tighten the chuck jaws using the chuck key. Remember to always remove the chuck key when done. Never get in the habit of leaving the key in the chuck. Large pieces of wood may rest on the table. If using small drill bits of a 1/4 inch diameter or less, clamping your wood to the machine table is not necessary. Just make sure to press down firmly on your piece of wood when drilling. Smaller pieces of wood might need to be clamped down. If you're using a large diameter drill, like a Forstner bit or hole saw, you should clamp your piece to the table. The woodshop has a variety of clamps, such as bar clamps, sometimes called F-clamps, C-clamps, pipe clamps, though these are more typical for gluing sections of wood together and not for clamping parts to the drill press, screw clamps, and vice grips. It's up to you to decide what clamp is best for the job. If you do need a backer board to support the underside of your piece, this is the time to put one in. A backer board supports the wood fibers as your drill bit is pushing to break through the other side. If the wood fibers are not supported, you typically have breakout, which results in a sloppy hole on the exit side of your board. Lower the bit using the feed lever and line up the bit point with the center mark on your part. You may need to move or reclamp your piece or adjust the table to make sure that your alignment is correct. Make sure to check and adjust the depth stop if needed. With the spindle fully retracted, turn on the drill press. Lower the spindle using the feed lever. Lightly touch the bit to the part. Check for alignment and possible walking. That's if the bit does not pierce the surface and is deflected. If everything looks okay, slowly plunge the bit into the material. It's a common practice to peck drill. Peck drilling is when the bit is retracted partially or fully from the hole after drilling a small portion of the overall depth. This allows for debris to exit the hole and allow proper heat dissipation by removing chips. Continue drilling until the full depth of your hole is achieved. Fully retract the spindle using the feed lever. Do not let the feed lever retract uncontrollably. Doing so will knock the chuck out of the spindle and is dangerous. Guide it back slowly into the return position. Turn off the drill press. Remove the bit using the chuck key and clean the area. Do not leave the chuck key in the chuck. Clean up your dust from the table and the floor. Sweep the surrounding area if necessary. Now let's have a look at adjusting drill speeds, which you'll have to adjust for different types of woods or materials like plastic, as well as drill bit sizes or drill bit types. You will have to adjust the speed on the drill press. Don't assume the speed is set to your application. This is a community shop. The machines are always being adjusted by different users. Speeds are measured in RPM, or rotations per minute. Smaller drill bits need faster speeds compared to large diameter bits. Cutters like hole saws and large diameter Forstner bits require much slower speeds. Therefore, adjusting the drill press speed is a very common practice. First, identify the speed you need based on the size of drill bit or drill accessory you're using. In this example, we have a 1/4-inch drill bit. A drill chart for wood is a good baseline for recommending operating speeds if you are unsure, but in the end, sight, sound, and experience are the best guides. You can always ask a staff member if you are unsure of the proper drill bit speed. Staff is always happy to help. In this example, we are drilling softwood. For this operation, we will choose 830 RPM, or rotations per minute. As mentioned previously, this drill press is not a typical wood drill press. It's a machine shop drill press. Because of this, it has much more torque, and subsequent of that, it's also directly driven by gears. This means changing the speed is slightly different than a traditional woodshop drill press, which is typically driven by belts and pulleys. To adjust the speed on this drill press, we have to make sure the machine is off. Consult the plate on the front of the drill press. Find the speed for your operation. If we look at 830 RPM, this chart says we need to be in the L2 speed. Remember, L2 is forward, R is for reverse. Drilling in reverse is not effective. These icons show the forward and backward positions of the gear levers. In this example, the upper lever should be set backwards. The lower gear should be set forwards. These levers need to snap or click into position. You might have to manually turn the chuck while pushing each lever to get the gears to mesh. Manually turning the chuck will get the gears to move and hopefully mesh when switching between speed settings. Check your speed by turning the drill on and off. Make sure the guard is closed when doing this. There's a big difference between the L1 and L2 speed settings, so check this if your speed seems incorrect. When marking your drill location, you can do more than just a pencil mark. You can use an awl or spring punch to mark your drill location. This will create a divot for the bit to start drilling. This little divot will prevent the drill bit from walking or wandering, which is caused by the material deflecting the bit. A punch will also assist when lining up your bit with the drill position. Do not use a spring punch or awl on plastic. This includes acrylic. A center punch, spring punch, or awl will likely crack most plastics if you try to make a starter hole or divot. If you need to make a large, uniform circular cutout, consider using a hole saw. We have a hole saw kit located here. This hole saw kit has a few arbors, which is the center drill that creates a pivot point around the circular saw. It also contains a large variety of hole saws in various diameters. The second part that creates this hole saw is the saw itself. These come in various diameters. Select the diameter you need and insert the arbor. Thread the arbor into the hole saw, turning it as far as it will go, but just enough so that these two pins will line up with the rear of the hole saw. Push these pins forward into the hole saw. Tighten the backing nut to keep these pins pushed forward in place. This only needs to be finger tight. Do these steps in reverse to disassemble the hole saw. Return the parts back to the kit when you're done. You can use a hole saw bit in a drill press or a hand drill, but just be careful. Large diameter hole saws will return lots of torque to the user. In a hand drill, this can go from unwieldy to extremely dangerous. Always consider the job at hand and ask yourself, does this make sense to do it with a hand drill? A drill press will keep you safe if you properly clamp your part to the table and keep your hands free of the cutting operation. Hole saws and large diameter Forstner bits will transfer lots of torque into your part, so make sure it is clamped securely. If your part is not securely clamped down, it will spin. If you're holding onto your part while this happens, this is the easiest way to break a few fingers. When using a hole saw, unlike a Forstner bit, a hole saw only cuts out a plug. This plug will become lodged in the hole saw. It has to be removed manually. Do this carefully. These cutouts on the side of the hole saw are for inserting a screwdriver to push this plug out. Just be sure to do this in slow pushes and increments at a time, just so the part doesn't get wedged. The drill press is a fundamental tool in the woodshop for making clean and precise holes. Although its operation can be deceptively simple, there are lots of details in the accessories. Take some time to get familiar with the types of drill bits mentioned previously. If you have any questions about speeds, setup, hold down methods, or just general what to do next, feel free to ask a staff member.